Okay, so we're taking a look at 2016, number 4. Okay, consider the differential equation dy dx equals y squared divided by x minus 1. So a differential equation, kind of cool. Part A, on the axes provided, sketch a slope field for the given differential equation at the 6 points indicated. Okay, so for a slope field, all you got to do is just plug in the points. This one's not too bad. What I would do is kind of group these together. So I'm going to look at these 3 points at the same time, or kind of reason through those 3 points. For all of those points, they all have something in common. And all of those points have an x-coordinate of 0, right? No matter which point I'm at, they all have an x-coordinate of 0. So let's take this dy dx, and let's plug in 0 for x to get started with. So y squared over 0 minus 1. So y squared over negative 1. So when I plug in my y values, it's just going to be the negative of the squared, right? So if I plug in 2 to that, the y value of 2, I'm going to get 2 squared divided by negative 1, which is negative 4. And we're going to do our best to sketch a negative 4 slope. Okay. For the next one here, 1 squared is 1 divided by negative 1 is negative 1. So not quite as steep. And then lastly, a slope of 0 at 0. I'm going to use a different color. Okay, so a 0 slope. Okay, for this one here, I'm going to use the same kind of reasoning for these 3, okay, because they all have something in common again. And for all of those, they all have in common that x equals 2. Okay. So y squared over 2 minus 1 would just be y squared over 1, or just y squared. So as I plug in these numbers, I'm just going to square the y coordinate, right? So for the top point here, y squared is 4, so this would have a positive slope of 4. When I plug in 1, I'm going to get 1, because 1 squared divided by 1, so a positive slope of 1. And then plugging in 2, or I'm sorry, a y value of 0, right? I saw the 2 and got confused, easy thing to do. But a y coordinate of 0, when I plug that in, I'll just get 0. Okay? So that's the slope field at the 6 points indicated. Okay? Part B, that f of x be the particular solution to the given differential equation with the initial condition f of 2 is equal to 3. Write an equation for the line tangent to the graph of y equals f of x at x equals 2, and use your equation to approximate f of 2.1. Okay, so there's a lot of information given there. They do tell us an initial condition. So maybe right away, because it said initial condition, maybe you're thinking fundamental theorem of calculus, maybe not, it's okay. But it goes right into the next sentence saying write an equation for the line tangent. Okay. So for the equation of a tangent line, I need a point and I need a slope. This is part B, isn't it? So, and it says at x equals 2. So for x equals 2, I have an x coordinate. I need a y coordinate. So for the y coordinate, I'm going to plug 2 into f. And because y equals f, f of 2 is equal to 3. I also need to find the derivative at 2. Right, to find the slope of the tangent line. So when I take 2 and plug it into the derivative, that's going to take dy dx. That's the derivative notation, right? These are the same notation, just they mean the same thing, just different notation. So dy dx, and we're going to take the point and plug in 2, 3. Okay? So I'm going to use the derivative at the top. So y squared, 3 squared over 2 minus 1. So 9 over 1 would just be 9. Okay? So your equation of the tangent line would be y minus 3 equals 9 times x minus 2. There's your tangent line. But it also says to use your equation to estimate or to approximate f of 2.1. So we're going to take 2.1 and plug it in. Okay, so 2.1 minus 2 is 0.1, so 9 times 0.1 equals 0.9. And then we're going to add 3 to get 3.9. Okay? So that's our approximation for plugging in 2.1. Part C, find the particular solution y equals f of x to the given differential equation with the initial condition f of 2 equals 3. Because it says to find a particular solution, we are going to need to solve the differential equation. So for part C, we're going to take dy dx equaling y squared over x minus 1, and we're going to solve that, okay? So when I solve this, we need to start by separating the variables. So anything with a y will need to go on one side, and anything with an x will need to go on the other side. So I'm going to multiply by dx, and I'm going to divide by y squared, okay? First step, separate your variables. Next, to get rid of the dy and the dx, I'm going to take the integral on both sides, okay? So this, on the left-hand side here, 1 over y squared is equivalent to y to the negative 2. And on the other side, I need to leave it as 1 over x minus 1. Okay? So the antiderivative for y is you add 1 to the power and divide by the new power. For the other one, the minus 1 part doesn't really affect anything. So if we think about what function has an antiderivative of 1 over x, remember that is the natural log of the absolute value of x minus 1. And we're going to include a plus c, right? That constant of integration. Yeah, there should be one on this side too, right? But when I move them all over, they're all going to be the same constant, right? So as long as we have a plus c at least once on this line, we'll be good. Okay? So what I need to do next is I am going to need to solve this for y. Okay? So somehow I'm going to need to get y by itself, and the way that we'll do that is we will multiply by y, okay, and then we're going to divide by the natural log. Okay, all right, and then now that I've got y by itself, I'm going to take the initial condition f of 2 equals 3. And I'm going to plug that in. So negative 1 over the natural log of 2 minus 1 plus c is equal to 3. Okay? So negative 1 over the natural log of 1 plus c equals 3. And the natural log of 1 is just 0. So it's negative 1 over c equals 3. Continuing to solve this, we would get c equals negative 1/3. So we're going to take this, we're going to take this and we're going to plug it in for the c in my y equals equation. So y is equal to negative 1 over the natural log of x minus 1 minus 1/3. Okay? Okay. For points. On part A, you're going to get 2 points, 1 point for your zero slopes, 1 point for the non-zero slopes. Okay? On part B, you are going to get 2 points, 1 point for your tangent line equation, 1 point for your approximation. On part C, you're going to get 1 point for separating your variables. You're going to get 2 points for your antiderivatives. You're going to get 1 point for your constant of integration and using your initial value, so that's 1 point, and then 1 point for solving for y. Okay? Now, on this one, on the solving the differential equation, it's important to note that the most you can get is 3 out of 5 if you don't separate. Okay? Wait, no, I'm sorry. 3 out of 5 if no plus c, if you forget the plus c, right? If no constant of integration, the most you can get is 3 out of 5. And then if you don't separate your variables, 0 out of 5. So if you don't separate your variables, I'll use that as y equals x, right? Separating the y and the x, you would get 0 out of 5. So once you kind of get it started, you're going to get most of your points, right? So good thing to kind of keep in mind. All right, let me know if you have any questions.